All right, welcome everybody. This session is about 20 minutes, and it's really to introduce you to how to craft your advanced process control application. I understand, obviously, that people will have different abilities and different backgrounds, but hopefully everybody can take away something useful from this session. I'm going to touch on how do you get started in terms of the journey of implementing advanced process control. You should obviously do a bit of research. I'll touch on that. Check what sorts of resources and skills are needed and what sorts of resources and skills you have available in-house. Make sure you get buy-in from your organization and really choose a good target process. And that'll give you some confidence once you've completed that work. So get started. I suppose one of the first questions you need to ask yourself is what kind of software or technology are you looking at implementing? There's various companies and suppliers, AspenTech, Honeywell, Aviva, Yokogawa, IPCOS, and I think if you do your own research, you'll find there's many good software providers. It could be the case that you already have some software available in-house in your organization that you are using already, but perhaps you yourself haven't used it. Maybe there's a historic implementation. You should also look at doing some research on what are the typical benefits for your industry. And these could be in sort of dollars per year. It could be intangible benefits like improved operation, better quality control, fewer alarms. And these are all the intangible benefits are sort of well known in the advanced process control industry. It's also a good idea to check who are the expert consultants or practitioners in your particular industry. Again, there's a lot of experienced people available who have many years of experience doing these types of projects. And it's always good to learn from them and perhaps accelerate your implementation and improve the overall design that you might come up with. So research is an important aspect. If you look at resources and skills, you want to create a team that embarks on this journey that consists of a variety of people within the organization. It could be process control engineers, DCS engineers, people from the operations department, could be planning department people if you have them, process engineers. And the idea is really to get an enhanced understanding of your process. And you need to have a very good understanding of the process so you can put together a design that really makes sense and can really be something that will be used easily by the operations department, your advanced process control application, that is. You also need to have a very good base layer control, meaning your PID loops should be in good condition. If you have some tuning work to be done, then you need to make sure you do that. If you need to reconfigure some tuning, some PID loops, then clearly that should be something you should discuss and change and improve. So, a bit of DCS skills needed there. In terms of data analysis, this is something quite generic these days. You're going to need to know how to understand process interactions, typically by looking at process trends. You can also use the advanced process control software to do some analysis there. So really this will give you a good understanding of upstream unit interactions with the unit you're working on, as well as downstream unit interactions. And you really need to have a desire to make an impact. It's fairly obvious as well, but you want to be able to help your organization benefit from the technology and really show the before and after trends to your organization in terms of how much benefit you have generated in doing your work. It's also very satisfying to see the operations department, for example, using your application that you built and really sort of putting their feet up and relaxing, because now they have some technology that is allowing automation of the plant and really sort of doing a bit of an autopilot for their section of the plant. So, you know, you really want to be making an impact there. A curious mind is always good, and in a technical sense, what this means is if there are things that have been done a certain way in the past, you know, and if you think that it's not correct, you know, challenge that and get to the bottom of why, for example, a particular PID loop is configured a certain way, and really try and see if you can make improvements, have discussions with people, and really try and get to the bottom of it and make those changes. So really, resources and skills fairly important, as you would imagine. Now, getting buy-in is an interesting one, because quite often these types of technologies are not very well known, and although they are very widespread, there are still many industries in which advanced process control is not well known. So really, you want to get your colleagues interested, show them the impact of the technology, and you know, there's a lot of information available in terms of papers, and you should be able to find relevant ones for your particular industry. And engage with an expert, again, from the point of view of generating information and understanding of what the technology can do for your particular industry. And in the end, what you want to be able to do is prepare a business case which puts together the benefits of advanced process control, the costs, you know, timescales, risks, and you can then present this business case to your management, which can then be used to, it can be scrutinized, and eventually perhaps you will get approval for doing the work. So really, the buy-in aspect is quite important, especially if your industry is not has not been touched, so to speak, by this technology. I think the industries where this is very prevalent, advanced process control is very prevalent, is typically in refining, petrochemical industry. There is some now coming into food and beverages and sort of mining and metals, etc. But there might be many other industries where this is not that prevalent, but don't be afraid of not, you know, I think the benefits are still there in all different industries. So get buy-in. Choose a target process. So this could be a small section of the plant where you're working, and make sure that the plant where you're doing this is well understood, and it's reasonably small scope, because what you want is to be able to do the work and show the benefits and gain some confidence for yourself as well as for the people who are using the technology, and that will then help you sort of springboard into doing bigger projects with larger scope and more benefit. Typically, the sorts of plants where or process units where this technology is quite useful is where it's energy intensive, and you have product quality constraints which are quite prevalent and really drive the process and the economics of your organization. It's also quite important to have good instrumentation in the plant where you are thinking about implementing this technology. And if you have analyzers, for example, measuring product qualities, you need to make sure that those analyzers are reliable and working well. And generally, the process unit has good instrumentation. Okay, so choose a target process. And now we need to get working on your project. Again, we want to look at the capability of the team you have assembled. You look at the methodology and the software of the advanced process control system. So you may have chosen certain software, and then you want to ensure that you're using the correct methodology to go through the steps to do the implementation. And communication is a mundane thing, but it's probably the most important thing, well, in life and also in these types of projects, where you really want to make sure everybody is well informed of what you're doing, and also you're getting all the feedback and the input from all the different stakeholders. And then I'll show you a little example where this sort of comes together. So in terms of capability, we touched on this previously. So that, at the research stage, you want to look at what sorts of capabilities you have in-house. But when you're obviously up and running and you've got a project in hand, you want to make sure that the team that you assemble really does have somebody who's leading the activity, which could be yourself as a process control engineer, for example, or a process engineer. And then you want to bring in all the experts, which is, let's say, the operations people who are operating the facility on a 24-hour basis, and they understand the dynamics of how the process works, and they understand the operational side of things. You also want to bring in process engineers who have a good understanding of how the process should be operated, what are the targets, and what are the constraints, what are the bottlenecks on the plant. So you want all that information available to you, so you require those people to be in the team. It's also important to understand how much time is available from all of those people. You don't need 100% time, but you do need 100% commitment so that people are made available when you require them. Again, you might want to subcontract an expert once you understand what is the capability of your team. For example, you might have somebody who has implemented advanced process control in the past, but they're not in your department anymore. They've got a promotion. They might be able to help you, but maybe you can't rely on them. So you still need to have a working team that's going to dedicate themselves to this work. So you might need to subcontract an expert. And again, there's the advantage of that is that you have somebody who can very quickly and easily understand your problems and your scope of your advanced process control application, and provide you with some good targeted input which will help you directly, and perhaps shorten the implementation time and improve the quality of the work that's been done. Training is essential for a team where, for example, people are new to this technology, and the training really is in two parts, two types of training, I would suggest. One is on the software itself. So if you're buying or you have, let's say, Honeywell's advanced process control software, then do the training on the software itself, so you understand how to use the technology and the software, but also on the methodology itself. How are you going to, what steps are you going to go through? And sometimes the software and the methodology sort of go hand in hand, although there are some good practices or best practices that you should adopt in any case. And don't forget that there is some post-implementation time requirements as well. So once you've completed the work, it's like any other technology, I guess. You need to pay attention to maintenance and make sure you have some time allocated from yourself or other people to to continuously ensure that the application is operating at its best. Now, in terms of methodology and software, I think this is quite an important step. You know, just buying the software and putting a design and implementing it is one approach, but you really need to follow quite a thorough approach, in my view, to ensure success. And by that I mean start with the base layer, make sure the PID loops are tuned correctly, make sure the PID loops are configured correctly. So if there's a cascade that you think should be broken, then make that case. Or if there's a loop that needs to be converted to a cascade, then again, make that case. And go through that quite carefully and understand that that is correctly configured before you go through and start building an advanced process control application above that PID layer. Also, you want to ensure that you're getting good process data and it's not compressed. This is extremely important. There are some databases from which you can extract data, but the data is compressed and you don't really see, for example, temperature changes which are, you know, less than 1 degree. And that's not very helpful from an advanced process control point of view. When you're building, when you're doing the data analysis and the model development, you want to be able to see, you know, all the raw changes happening in the process with high fidelity. Otherwise, you will not end up with a good model and a good advanced process control system. Again, fairly obvious who does what. Obviously, people will in your team gravitate towards their core skills, so which is fine, but it's quite important. If you are using subcontractors, etc., you define very clearly what their scope is and really understand the capability of your team and make sure you seek help and advice as and when needed. If you believe your team is well equipped and you have resources available within your organization on whom you can rely for information on advanced process control or prior applications that have been developed, fair enough. But if you don't have that knowledge and information, then, you know, do reach out and seek advice from external parties, such as independent consultants or even the software vendors, consultants, and other people. So, you know, be very clear on your capability and the lack of knowledge and how you can fill those gaps. Software training is a must. Again, quite obvious. Must be able to drive the software correctly so you can really understand how to get the best out of the software in terms of the development stage of the models and also the implementation stage. As you can imagine, the whole business of developing an advanced process control application is quite a long topic, so I'm not really addressing that, and I'm deliberately not getting into that kind of detail, but I'm just trying to give you a flavor for what you really, the ingredients you need before you set off on your journey to develop an advanced process control application. Communication is extremely important. I can give you several examples, which I won't go into now, where projects that I have worked on have been very successful and ones that have not been successful, and I would just put it down to communication. It's really sometimes that simple. And communication is about bringing everybody in the fold, making sure people are informed and really they feel part of the team. I mean, it's not about, it is about the content. It's also about what you communicate, but it's also about making people feel part of the team. And don't forget, your final customer is the operations people. If I'm an external consultant coming in and I'm working for company X, yes, I am contracted by company X, but I really see myself delivering to the person who is operating plant 24 hours a day, because they are the ones who are eventually going to use it. And it's the same for the employees of company X. If they are doing a project in-house, then they're really catering to the operation staff as their final customer, because they are the ones who are really using that technology 24 hours a day. So make sure that the operations people are really part of the team, and you really bring them in the fold for all key decisions. So I'm going to take a little example here. Forgive me, this is a refining example. The image is taken from sciencedirect.com. So it's just a generic gas plant where you have a deethanizer column. So you have a feed stream coming in which contains natural gas liquids and ethane. And really you are separating it out into ethane, propane, butane, and all the heavier material, which is pentane plus. This is just a typical example, but your process could be different. It could be several different units by themselves, but I think this example demonstrates some of the key points that I'm wanting to make here. So let's say, for example, we focus on just a section of the process. This part marked in red, and we decide we want to do an advanced process control application on this particular unit, which is the debutanizer column in this case. So the first thing to do is understand the boundaries of your process. So you want to know, in this case, what is coming in and what's going out of the process. Fairly straightforward. In this case, we have the feed coming from the upstream column, which is the depropanizer, and then we have the products going out here, which is the butane and the pentane and heaviers going at the bottom. The manipulated variables, these are the variables that the advanced process control system will manipulate and send the set points to. If you look at the temperature at the top and the steam flow in the bottom, we can consider those as our manipulated variables, because they will have a big impact on the product quality, which is in this case an impurity, which is the C5 content in the butane. And in the bottom, it's the Reid vapor pressure, which is basically a measure of the light material which is being slipped into the pentane. So you want to make sure both of these are within a specified target. So for example, this could be 2% C5 maximum in the butane, and the Reid vapor pressure could be whatever, 10 psi or something. And then you have disturbance variables. So these are the variables that will affect the operation of this debutanizer, but you just have to take that impact because you can't control those variables. And I've said, for example, the temperature and the flow coming in here. But you also have to remember that the temperature and flow could be correlated, so they could be dependent on each other, in which case you can probably use only one or the other. So you can use either the temperature or the flow. But this is something that you would probably investigate as part of your process of building the application. So some things to think about. You will have some propane going in the butane, but there's nothing you can do about it from this column because that's coming from the previous column. There might be some effects of the ambient temperature on this column, and you might have to look at that. There might be some pressure effects. We haven't included the pressure here, but there might be some pressure effects, and you might want to look at that as well. So these are the sorts of things that you want to be considering. This is a very small, compact application, but I think it demonstrates the point quite well. In terms of benefits, once you've implemented this little application, you should see energy reduction, basically a reduction in steam usage. You might have improved quality control if this standard deviation of the C5 in butane was, let's say, 0.5%. You can maybe cut it down to 0.2% because of improved control of that particular quality. And you can then calculate the benefits associated with that kind of benefit. And it's nice and small scope, so it's easy to explain to people. You get a good feeling about a nice, you get a good amount of, I would say, confidence from doing something small and compact like this. So once you've done this, you might want to include upstream columns as well as part of the scope. And this could be the deethanizer and the depropanizer as well. And so this could then give you the full benefits of the rest of the gas plant as well. Okay, so this is sort of like an extension. So I'm just going to summarize now. So I would say if you're embarking on a journey for, getting your first, second, whatever a new advanced process control project, the organizational aspects are just as important as the technical aspects, because you're going to have to work with people, and you really need to ensure that you've got all the things in place to make that that project a success, including people, technology, and also the scope of the project, of the unit that you're looking at. Choose a small process to gain experience and boost your confidence. If this is the first of many, then do a small one first. Make sure you train colleagues to ensure longevity of the application, because once you've done the work, you want to ensure that the application is going to continue operating for a long period of time, and it just doesn't sort of stop once the work is done. And also develop new applications and ensure you maintain old ones. So as you're developing new ones, for example, you're expanding that application that you did to the deethanizer and depropanizer, and you include the debutanizer as well. Make sure that other applications you may have done are also maintained, so that you can continue on the journey and complete, for example, implementation throughout your organization or your asset. That's all I have. Thank you very much for your time, and I will take some questions now if you like.
If I may ask.
Yep.
In this debutanizer column, you mentioned that you will be using the top temperature TC as one of the manipulated variables.
Yeah.
Is it common in APC applications to call temperature as a manipulated variables? Otherwise, base layer controllers, we never call. It's seldom temperature is chosen as a manipulated variable. It could be either control variable or a disturbance variable. Can you elaborate on that, please?
Yeah, I think the temperatures are quite commonly used as manipulated variables. I mean, depends which one. But in this case, the temperature would be a part of the base layer scheme in any case, because in a distillation column, normally you will have one temperature that is controlled in the column, either the top temperature or the bottom temperature.
Yes.
In this case, I've taken the example as the TC in the top. And okay, if we manipulate the TC, then you will end up getting, yeah, the set point, you'll end up getting.
Set point, okay, yeah, understood.
Yeah.
Thank you.
Okay. Any other questions?
Yeah, I might ask one. Thanks for the overview, Sam. It's very good coverage of a bunch of things. One thing I was wondering is whether you could quickly touch on this thing of estimating the benefit of projects. Like I see that especially as you move into like newer or the kind of in sectors where people are not familiar with this, people are like, okay, can you tell me upfront what the benefits will be? And just from kind of analyzing process data, it's quite hard to kind of, yeah, I don't know if you want to say something about those benefit estimations upfront.
Yeah, I think that's a good question, Neil. I think it is possible to get the benefits from looking at process data. We have to sort of home in on where, for example, is it energy intensive process? Is there particular areas where a lot of energy is being used? What are the measures of quality, or what are the measures of reducing energy in that particular part of the plant? And is there instrumentation that can measure that? So it is possible to do that even in strange processes. I think if we have the particular data, it's not that hard to do. But it's a collaborative effort. We'd have to get some of the experts from the asset involved, for the company involved, to understand what their experience is, and then come up with some, it's sort of marrying the data with the capability of the technology, and then coming up with what is feasible. So yeah, feel free to reach out if you have any particular ones that we can discuss offline. Yeah.
Thanks.
Okay, I think that is all we have. Thank you so much for joining, and